Celestial objects. So at the end of this lesson, students should be able to describe the relationship between various celestial objects, including moons, asteroids, comets, planets, stars, the solar systems, galaxies, and space itself. So astronomy. So what words do you think of when you hear about the word astronomy? So just pause the video maybe and write down what comes to mind when you think about the word astronomy. So what you might think about are things like Earth, planets, stars, comets, things like that might come to mind. Stars, for example, comes to mind a lot for people. So what is astronomy? So astronomy is the study of the universe beyond the Earth's atmosphere. So around the Earth, you have an atmosphere, and once you go outside of that, you're in the realm of astronomy. And this is what, if you're an astronomer, is what you're interested in looking at and studying. So celestial bodies then. Celestial body is a naturally made object outside the Earth's atmosphere. So they're objects that are made by nature. And we'll have a look at some of these bodies now that are in our universe. But just to think in contrast to that, we have other objects that are outside of the Earth's atmosphere, like the International Space Station, which is this here, and we also have the Hubble Space Telescope. So these are man-made objects, and they are outside the Earth's atmosphere as well. So again, just in contrast. So a celestial body is a naturally made object that is outside of the Earth's atmosphere. So the first kind of naturally made objects that are outside the Earth's atmosphere are the planets. And we live inside the solar system, and this is our solar system here. And we have the sun, which is this here. So the sun is massive in comparison to the other, in comparison to the planets. So most of the mass of the solar system is in the sun itself. So this is a huge object, and planets then orbit around stars. So all of the planets in our solar system, they revolve around the sun. And these are the planets that are in our solar system. So you have the planets that are closest to the sun. These are what are called rocky planets. They're also called terrestrial planets, and they're mainly made up of rock and metal. And that makes sense because if you think about these planets, they're very close to the sun. You're going to have much higher temperatures in here, and the rocky and metal planets are going to have a much higher probability of surviving the heat of the sun. You have then an asteroid belt. Okay, so you have this asteroid belt here, and then outside that then you have the gaseous planets, or the Jovian planets, and they're mainly made up of hydrogen and helium. So as we go from here to here, the temperature starts to dramatically drop and decrease, and that allows these Jovian planets to survive out here in the cooler regions of our solar system. So the planets then are Mercury, Venus. So this is starting from, let's say, the ones that are closest to the sun to the ones that are furthest away from the sun. So we start with Mercury, Venus, then we have Earth, then we have Mars. So that's these guys here. Then we have this asteroid belt. Then we have Jupiter, Saturn, Uranus, and Neptune. So that's these gaseous planets out here as well. So an easy way to remember these planets and the order of them is this acronym here. My very easy method just speeds up naming. Okay, so the first letter of each of the words represents the first letter in each of the planets. So it's an easy way to try and remember the planets that are there. So planets are objects, they orbit a sun. They have they've cleared their own path. They're big enough to clear their own path in that there's nothing that gets in their way when they orbit around the sun. So that is the first kind of celestial body we're looking at are what are called planets. So I mentioned that the planets, they are in orbits and they orbit around the sun. So for example, it takes the Earth 365 days to rotate or orbit around the sun, and that's what we call the calendar year. And all of the other planets in our solar system are doing exactly the same thing, but it's just taking them different amounts of time to orbit around the sun. Now there's no direct contact between the sun and the Earth. So between the sun and the Earth you have just empty space. So how is it that the sun is able to exert influence on the Earth and make it rotate around it? Well, that force that it uses is what's called gravity. So gravity is a force that attracts objects towards each other. So the more mass an object has, the greater its force of gravity. So the bigger an object is, the bigger its force of gravity. So gravity forces between the Earth and the Moon, for example, keep the Moon in orbit around the Earth, and gravity forces between the Sun and the Earth keep Earth in orbit around the Sun. So this force of gravity is what keeps everything in motion around the Sun. So gravity is directly linked. The amount of gravity an object can exert on its surroundings is related to its mass. So the mass of an object is the amount of matter or stuff it contains. So the biggest amount of mass in our solar system is in our sun. It's a massive object, contains huge amounts of matter. The more matter an object contains, the greater its mass. So, and the greater its mass, the greater its force of gravity. So as an example, what do we mean by matter? So an elephant contains more matter than a mouse, so it has a greater mass. Okay, so that's what we mean by that. So again, if you take the size of the Earth, it's massive in comparison to the size of our bodies. So again, the Earth, because of its mass, because it's so big, it's able to exert a huge amount of gravity force on us, and that's what kind of keeps us attached to the Earth. If you were to turn off the power, if you were to turn gravity off, basically, we would float off into space. So we would. So this force of gravity is very important. It's the glue that holds the universe together. So I mentioned that we have a moon that orbits around our Earth. So basically, moons orbit planets. So a moon is an object that orbits a planet. So Earth has one moon, and if you look out at night, if it's a clear night, you'll see our moon. A moon is a natural satellite of a planet. So moons always orbit around the planet, or they're what are called satellites. Later we'll look at other planets in our solar system and the number of moons that each of them have as well. So we'll have a look at, so the Earth has one moon, but there's other planets that have many moons, and we look at those as we move on through this lesson. So again, what is a moon? A moon is an object that rotates or orbits around a planet. So we mentioned a star, for example, our sun. So what are stars? So a star is an object that it can generate its own light and its own heat. So it's a luminous object. It can generate its own light and heat. So it's a big ball of burning gas. So it's generally hydrogen that's being compressed by the force of gravity. That's causing what's called a nuclear reaction, and it's causing like a nuclear explosion in space. And that's essentially what stars are. They're like controlled nuclear explosions that are happening in space. Different stars burn at different temperatures. So the hottest stars are blue in color, so they give off blue light. And the colder stars are more red in color. Stars are spherical in shape, and they're not actually star shaped. So moons orbit planets, and then planets orbit stars. So at the center of most solar systems is a star, and the planets orbit around the sun, and then moons orbit around the planets. So other celestial bodies that you'll find when you look out into space are what are called asteroids, and I mentioned the asteroid belt that's just the far side of Mars. So an asteroid belt is a small rocky object that orbits a star, and it's too small to be considered a planet. They're kind of irregular in shape, so they're not like spherical, for example, and they're found between the orbits of Mars and Jupiter in the asteroid belt. So I mentioned that. So if we look on the Earth, there's evidence, for example, where asteroids have struck the Earth, hundreds and thousands of years ago. They reckon that one particular asteroid that hit down around Mexico, so in around here, was responsible for wiping out the dinosaurs. So when it hit the Earth, it threw up loads of dust and debris into the atmosphere, and what that done was it blocked out the sun. And when it blocked out the sun, it stopped basically the food source. Like bigger animals were because bigger animals were not able to get their food source um, because because of the sun being blocked out. Bigger animals basically died off because they weren't able to get their sources of food. So smaller animals survived like mammals like us, and insects, whereas bigger animals like dinosaurs, which need to consume an awful lot of food every day, died off. So basically, there was a massive drop in temperatures all across the Earth. So herbivores, big herbivores, would have died off because they wouldn't have been able to get access to food because it would have been frozen over. And then as a result of that, animals that preyed on them died off as well, bigger dinosaurs. And then as a result of that, there was like what's called a mass extinction event. And that was brought about by an asteroid striking the Earth. So similar to asteroids, then you have what are called comets. So a comet is a small object made up of, so it has like rock in it, but it also has frozen gas and ice. And there's also dust in it as well. And it can actually glow and produce a tail as well. So if you look at this painting here, it's of the Great Comet in 1811. We can see that it has this big tail that comes out from it. So this is an artist's depiction of a comet that was observed in the sky back in 1811. So what happens is comets basically they orbit the sun, and when they come close to the sun, they heat up. And when they heat up, what happens is this frozen, so frozen gases, for example, they start to turn back into a gas, and you get this like trail that's left behind it. Um, so where are comets located? So we have these main regions where comets come from. So if this is our solar system, and if you go to the very edge of our solar system, you have this belt called the Kuiper belt, and it's pretty cold out around there. So you have comets that are moving around or just floating around outside here as well. And then even further outside of that, then you have what's known as the Oort cloud. So this is like a massive cloud that basically encapsulates the Kuiper belt and also as well our whole solar system. And that's just full of comets. So sometimes some of those comets will just get knocked off course and they'll start to make their way in through the solar system. And then as they get closer and closer to the sun, the heat causes the frozen gases to start to evaporate, and it causes these long clouds that we see. And that's sometimes you can see them in the sky. You'll see comets are like shooting stars. So galaxies then, so a galaxy is a large group of stars, dust, gas, and dark matter held together by gravity. So this is like what a galaxy is. Um, so everything that we've kind of talked about is contained, if you like, within the galaxy, and they can be different shapes, but most of them are spiral in shape. So they have this like spiral shape like this that we see here in this depiction. The galaxy that our solar system is in is called the Milky Way. So just to kind of put it into context, so we would be a tiny little dot just about here on one of these arms in the Milky Way galaxy. So solar systems make up galaxies. So the galaxy itself is made up of like billions of stars and other solar systems. So just to kind of give you an idea, and then what happens then is these galaxies, there's billions of those, they make up what's called the universe. So if we take, for example, our solar system, it's contained in here. So if you just take our galaxy, just to give you an idea of how big it is, so it's around 13.61 billion years old. That's how long they think it took to form. It has a radius of 52,850 light years. So because things are so big in space, we have to measure them using a unit called a light year. So a light year is how long it takes a beam of light to travel in 1 year, and that's like a light can travel very, very fast, and long. It can cover long distances in no length of time. So just to kind of put it into context, if you were somehow able to get out to this end of the galaxy and you're to shine a light across here, it would take 52,850 years for that light to travel the whole distance from here and get over here. So if you were on this side of the galaxy and you were to look in this direction when the light was shone, you wouldn't see it for 52,850 years. That's how big these galaxy structures are. And this galaxy is just like one of many galaxies that make up the universe. So it's mind-bogglingly big. The universe is a huge place. And contained inside here in this tiny little dot is our whole solar system. Okay, so there's around 100 to 400 billion stars, and our solar system is just one of those stars. one of those stars makes up the center of our solar system, which is the sun. So our solar system then, our solar system is a group of planets, asteroids, comets that are in orbit around a star, and they're held together by the star's gravity. So gravity, as I say, is what holds all of the planets together. So essentially the solar system then is made up of all of these celestial objects that we've talked about, and planets and stars make up solar systems. So that's what's known as a solar system. So what I'd get you to do, we're going to look at some of the data in relation to these planets. So if you copy down this table here into your copy, and what we will do is we will go through, and I want you just to take down the information for each of the planets as we move through it. So, and what we're going to do a little bit of a study. So what do you think happens, the surface temperature of the planets, the further you move away from the sun? So we're going to start with Mercury, and we're going to work our way right out through our solar system and look at the planet data in relation to each of them. And we'll try and see if there's any pattern that we can observe. So the first object in our solar system is the sun. In relation to the mass, its mass it's 333,000 times the mass of the Earth, so it's massive in comparison to the Earth. This is its diameter, so if you were to measure from here to here, that's how many kilometers across it is. This is an actual image of the sun. And if you take the temperature on the surface of the sun, it's 6,000 degrees Celsius. So just to kind of put it into context, water, boiling water, when you boil your kettle to make your tea, it's 100 degrees Celsius. So think about how hot that steam is that comes out of the kettle. But imagine then how hot the surface of the sun is in comparison to that. 6,000 degrees Celsius. So it's absolutely very, very hot. So the first planet then that we come across is Mercury. And if we take its mass in comparison to the Earth, that's its mass in comparison to the Earth. So it's a fraction of the Earth's mass. That's its diameter. So if you were to measure from one end to the other, that's how many kilometers across it is. That's its distance from the sun. And that's so it's 58 million kilometers. The length of time it takes for it to do one rotation around the Earth is that number of Earth days. Time taken to just do one rotation on its own axis is 59 days, Earth days. So if we take in comparison to the Earth, it takes 29 Earth days or 24 hours for our planet to do one rotation on its axis. And if you take its surface temperature, it's up there on 350 degrees Celsius. So that's its surface temperature, and it doesn't have any moons. The next one out then is Venus. So that's its mass in comparison to the Earth, its diameter, its distance from the sun in millions of kilometers, the time it takes to do one orbit around the sun, the time it takes to do one orbit on its own axis, and then its temperature, its surface temperature. It's up in 460 degrees, and it doesn't have any moons either. So the Earth then, if we look at the Earth, so its mass, that's its mass. Its diameter across, it's pretty big. That's its diameter across in kilometers. Its distance from the sun, that's how many millions of miles away, millions of kilometers away it is from the sun. The time it takes, so that's 1 year. So it takes 365 days to do one orbit around the sun, which is a calendar year. It takes 24 hours, which is a day, in order for it to do one turn on its own axis. And then its surface temperature is 20 degrees, and it has one moon. So the next one out then is Mars. So again, that's its size in comparison, mass in comparison to the Earth. That's its diameter, its distance from the sun, time it takes to do one rotation around the sun, time it takes to do one rotation on its own axis, and then the temperature on Mars as well. So it's minus 23 degrees Celsius. So it's pretty cold. And Mars has 22 moons in comparison to one moon on our planet. So Jupiter then. So Jupiter is much bigger than the Earth. You can see it's 318 times the size of the Earth. It has a huge diameter in kilometers. its distance from the sun, time taken to travel around the sun. It actually takes years as opposed to days. Time taken to do one rotation on its own axis, and then the surface temperature. We can see it's very cold, minus 120 degrees. So remember, water freezes at 0 degrees. So imagine how cold minus 120 degrees is. And it has 16 moons, and it has one outer ring then as well. So Saturn then is the next one. So it's 95 times the mass, 95 times the mass of the Earth. That's its diameter, so it's pretty big. Its distance from the sun in millions of kilometers. Time taken to travel around the sun. Time taken to spin on its own axis. And then you can see here that its surface temperature is minus 180 degrees. And it has 17 moons, and plus it also has rings as well. So Uranus, so this is the size of that planet, so it's 14.5 times the size of the Earth. That's its diameter, its distance from the sun, time taken to travel around the sun, time taken to do one rotation on its axis, and its surface temperature is very cold as well. It's minus 210 degrees, and it has 15 moons and one ring around it. And then finally Neptune. So Neptune has a mass of, its mass is 17.5 times that of the Earth. This is its diameter, distance from the sun, time taken to do one rotation, one orbit around the sun, time taken to do one rotation on its own axis, and then its surface temperature is minus 220 degrees, and it has 8 moons. So these are all the individual data points in relation to the planets that are in our solar system. So hopefully you've recorded all of that, and we've recorded in the table, and we'll have a look at this table. So what can we say in relation to the planet data? So what do you think happens to the surface temperature of the planets the further you move away from the sun? So we can now conclude that as we move out from the sun, the temperature decreases. So we can see here, so this is the surface temperature of the sun. And then as you move out, we can see that the temperature is starting to dramatically drop. So it goes from 350 degrees Celsius to minus 220 degrees Celsius. So the more we move out away from the sun, the colder it actually gets. Other things that we can notice as well is that if we take, for example, the amount of time it takes for the planet to travel around the sun, that also increases the further we go out away from the sun. So for example, we're going from, in Mercury, it's 88 days, whereas if we move all the way right out to here, we're talking 165 years just for Neptune to do one orbit around the sun. So we can see there's all kinds of patterns that we can look at here in relation to this. So that's just some planet data and just some of the kind of patterns that you can see in relation to both. So something that I haven't mentioned in relation to in our planet, in our solar system, are what are called dwarf planets. So a dwarf planet is a round sphere object that circles a star but has not cleared its own orbit. So they do not have enough gravity to pull the smaller objects in. And can you think of an example of a dwarf planet? So one example of a dwarf planet is what's called Pluto. So Pluto is not actually a planet, it's called a dwarf planet, and the reason being is that it can't clear its own orbit and it doesn't have enough gravity to pull objects into it as well. So it's what's known as a dwarf planet. Okay, so that is the celestial bodies in our solar system. So let's just go back to our learning outcome. So students should be able to describe the relationship between various celestial objects, including moons, asteroids, comets, planets, stars, solar systems, galaxies, and space. So if we take, for example, moons orbit planets, asteroids and comets and planets orbit stars. Solar systems are made up of stars which have planets and moons and asteroids and comets rotating around it. Galaxies are made up of solar systems, and then the universe and space itself is made up of billions of galaxies then as well. So hopefully that makes sense, and thank you for listening.